Today we're going to talk about different ways to describe data. The first thing that we're going to talk about are the different measures of central tendency. The first measure of central tendency we have is called a mean. The mean is the sum of the values in a set divided by the number of values. For example, if I'm given a set that includes 2, 3, 5, 6, and 9, my first step is to add those numbers together. So I'm going to add all those values together, which gives me 25. I'm then going to take that number, 25, and divide it by the number of values I have. So for this example, I have 5 different values. So I'm going to divide by 5. When I divide by 25 by 5, I get 5. So for this example, the mean is 5. Now, sometimes you might see mean also written or denoted by X with the bar above it. So anytime you see this symbol, know that they're talking about mean. The next measure of central tendency that we're going to talk about is called a median. The median is the middle value when the set was ordered numerically. So if we look at this example, first thing we have to check, are my numbers in order from least to greatest? When I look at these numbers, I know they're not in order, so I have to rewrite them in order. So when I do that, my order should look like this now. From here, I'm going to mark off a number from each end until I come up with the number in the middle. When we do that, we notice that we have one middle number, 6. So for this example, my median is 6. When we have an odd number of values, we will always have one number in the middle. But if there's an even number of values, then you will have to add the two numbers that are in the middle together and then divide by 2. So let's look at this next example. The first thing I have to do is put the numbers in order. When I do that, I get this, 2, 3, 3, 4, 5, 6, 6, 8. From here, I have to mark off numbers from each side until I come up with the numbers in the middle. So for this example, I have numbers 4 and number 5 in the middle. So now I have to add those two numbers together and then divide by 2. When I find that answer, I get 4.5. So the median of this example is 4.5. The last measure of central tendency we're going to talk about is called a mode. The mode is the value or values that occurs most often. Now, let's say, for example, I have a data set that has one of each number in the set. If that occurs, which means each number only occurs one time, none of them duplicate, then that means I have no mode. So if every number is only written once, you do not have a mode. But let's look at this example. My first number is 3. So I'm going to take 3 and count how many times does 3 occur. I have a 3 right here and a 3 right here, so it occurs 2 times. The next number in my set is 6. How many times does it occur? Well, I see 1 here, 1 there. So it occurs twice. 2, 1 time. 5, 1 time. 4, 1 time. And 8, 1 time. So if I look at how many times each of my numbers occur, I notice that 3 and 6 both occur twice. So since 3 occurs twice, and 6 occurs twice, then the mode of this example is 3 and 6. I can have more than one mode. That's okay. I can have more than one, I can have exactly one, or I can have none. So those are the 3 different measures of central tendencies. The next thing that we're going to talk about is called variance and standard deviation. Variance is the average of squared differences from the mean. So for example, if I have 6, 7, 7, 9, and 11, the first thing I have to do is find the average. Let's remember, average is the same thing as finding the mean. So the first step I have to do is find the mean. When I find the mean of that data, I find out that my mean is 8. So I need to keep that number in mind. I got to use that number later. The next step is to find the difference between the mean and each data value and square it. So I'm going to use a chart to help. So in my chart, I have my x values. Then I'm going to fill in my numbers. So I have 6, 7, 7, 9, and 11. Then I'm going to take my value and subtract my mean. So I'm going to take 6 and subtract 8. So that gives me negative 2. And then I'm going to do the same thing for 7. 7 minus 8 gives me negative 1, and so forth until I use all of my data values. So once I fill in these values, I'm then going to square those numbers. So negative 2 squared is positive 4. Negative 1 squared is 1. And then so forth until I get to my last number of 3, square 3, and that gives me 9. But I'm not done yet. To find the variance, I have to take the average, or the mean, of these numbers. So that means I have to add those numbers together and then divide by the number of values I have. Once I do that, I will find the variance. So for this example, I'm going to add 4, 1, 1, 1, and 9 together and then divide by 5, which gives us 3.2. So now let's look at standard deviation. If we compare what variance is and standard deviation is, we can see something that they have in common. They both say average of squared differences from the mean. The average of squared differences from the mean. So really, the only difference between variance and standard deviation are these two words right here, square root. So once we find the variance, to find the standard deviation, all I'm going to do is take the square root of the variance. So let's use the previous example. We found out that the variance was 3.2. All we're going to do to find the standard deviation is take the square root of 3.2, which gives us 1.8. So for this example, our standard deviation is 1.8, while our variance is 3.2. Now, we know that the mean can be denoted as x with the bar above it. Variance is denoted as like an O with a loop in it, squared. So standard deviation is denoted by the O with the loop in it without the square. The last thing that we're going to talk about today is called an outlier. An outlier is an extreme value that is much less or much greater than the other data values. An outlier is any number that is more than 3 standard deviations from the mean. Now, do not to assume that just because one number is very, very large or very, very small compared to the other numbers, that it's an outlier. If it asks you to find the outlier, you have to show proof. So you need this tip. Any outlier is any number that is more than 3 standard deviations from the mean. So let's look at this example. 2, 4, 5, 3, 5, 6, 123, 4, 2, and 1. So we're looking at 123. 123 is a lot bigger than the rest of those numbers. So to find out if 123 is truly an outlier of this data set or not, we have to prove it. So I need two things. I need to know what the standard deviation is and what the mean is. First thing I have to find is the mean. So once you find the mean, you should get 15.5. Once we find the mean, the next thing we have to find is the variance. We have to find the variance in order to help us find the standard deviation. Because in order to find standard deviation, all I have to do is take the square root of the variance. So my standard deviation is 35.86. But we have to identify if the number is an outlier by seeing if it's more than 3 standard deviations. So when I do 3 standard deviations, I'm going to take 35.86 and multiply it by 3, which gives us 107.6. But it's from the mean. So that means I have to take my mean, which is 15.5, and add 107.6. When I add these together, I'm going to get 123.1. Because 123 is less than 123.1, I know that 123 is not an outlier because it's less than 3 standard deviations from the mean. It's close, but it's still less than 123.1.